Welcome everyone. Our, our project today is the Morse code translator, the simple tool to decode a timeless language. This project is an electronic device that reads Morse code and translates it into English text. Key features: manual input. The user can enter Morse code manually using dedicated buttons for dot and dash. Real-time translation. The translated English letters appear instantly on a clear LCD screen. Underlying disciplines. This project combines electronics, programming, and communication systems, showing how legacy technology remains relevant today. Morse code still matters in connected world. Morse code is important because it works even in difficult conditions where modern technology might fail. So it's flexible, reliable, and universal. Flexible because it can be transmitted using light, sound, or electrical signals. Reliable because it requires very little power and simple equipment. Finally, it's universal because of the basic code is understood globally in specific contexts. So it's a simple system, but can be very powerful. A language of dots and dashes. Morse code is a method of communication that uses only two signals, a short signal dot and a long signal dash. History nugget. It was invented in the 1830s by Samuel Morse. It revolutionized long distance communication for the telegraph system. And here we have some examples for Morse code in that table. Project goal is making Morse code accessible. A primary objective to build a low-cost and simple system that can capture Morse code and translate it clearly into English text. Specific aims to make Morse code easy to use and learn, to provide instant, clear translation on screen, to create a platform for education and demonstration. The anatomy of the translator. The brain. Arduino board reads input, processes the Morse code logic, and controls the output display. The input push buttons. Two buttons allow the user to manually enter a dot or a dash. The display I2C LCD screen shows both the Morse code being entered and the final translated English text. The connection wires and breadboard connect all the components together to form the circuit. The logic from button press to English text. The program is written in Arduino language based on C++ to read the buttons and perform the translation. Our program will start with system ideal, waiting for inputs. If button pressed, identify the signal, dash or dot. Store the signal in the sequence as a sample. If it detected, translate the sequence via lookup table, and then display the letter on the LCD screen. Overcoming challenges in the build. Challenge 1. Input timing and accuracy. The system could sometimes misinterpret rapid button presses or confuse the end of one letter with the start of another. The solution: implemented prices delay functions in the code to create clear time windows for input and to define the path between the letters. Challenge 2. Efficient code structure, storing and searching the entire Morse code alphabet could be slow or inefficient if not organized well. The solution: use data structures like arrays to store the Morse patterns, allowing for fast and organized lookup using conditional logic, cases, and use cases. Education: an interactive tool for students and hobbyists to learn and practice Morse code. Assistive technology can be adapted as a communication device for individuals with severe motor disabilities. Emergency communication: a simple low power backup device for sending and receiving messages when primary systems are down. Hobbyist electronics: classic rewarding projects for anyone learning about Arduino and embedded systems. Feature development: count state version 1.0, manual input via push buttons. Proposed improvement version 2.0, add a sound sensor. Integrate a microphone model to detect audible Morse code signals. This would allow the device to automatically listen to and translate broadcasted Morse code from a radio or other sound source, making it a passive receiver. Finally, old code, new technology give us a powerful combination. Project summary. This project successfully demonstrates how a historic communication system like Morse code can be revitalized with modern, accessible technology like Arduino. Key learnings: it is a simple, low cost, and highly educational tool. It provides a practical experience in electronics, programming logic, and communication principles. It proves that the most effective solutions are often a blend of simple, reliable ideas and modern information. And thank you for listening.